Right now, somewhere in the world, a robot just built your smartphone in 0.3 seconds. Another one assembled a car door with zero mistakes. And in the next 15 minutes, you'll see exactly how they do it and why the future belongs to them. Welcome to the world where machines think, learn, and build our future. I'm taking you inside a real industrial robot factory today. You'll see things most people never get to witness. Stay until the end. You won't believe what's coming next. Welcome to the world where machines think, learn, and build our future. I'm taking you inside a real industrial robot factory today. You'll see things most people never get to witness. Stay until the end. You won't believe what's coming next. This is one of the most advanced robot manufacturing facilities in America. Behind these walls, over 2,000 industrial robots are built every month, each one designed for a specific mission: speed, precision, and zero error. Look at this. Rows and rows of robotic arms. Some welding, some assembling, some packaging. It's like watching a symphony, except every musician is made of steel and circuit boards. So, what exactly is an industrial robot? Simply put, it's a programmable machine designed to perform tasks automatically. It has joints like we do, motors for muscles, and a computer brain that never gets tired. Every industrial robot has three core components: the mechanical arm, the control system, and the end effector. That's the tool at the end, like a gripper, welder, or drill. Think of it as hand, brain, and tool all working together. There are many types: articulated robots with rotating joints, Scara robots for fast assembly, Delta robots for lightning speed picking. Each one built for a specific job, and they're everywhere. Automotive plants, electronics manufacturing, food processing, pharmaceutical packaging, even surgery rooms. Industrial robots are the invisible workforce building the modern world. Now, here's where it gets fascinating. This entire factory runs on automation. Robots building robots. It sounds like a sci-fi movie, but it's real. And it all starts with raw materials: steel, aluminum, motors, sensors, circuit boards. Everything arrives here in massive shipments. Automated forklifts carry them inside. No human touch yet. The process has already begun. Watch this robot. It scans every incoming part using laser sensors. Wrong size? Rejected. Damaged surface? Out. Only perfect materials move forward. This is quality control at stage 0. Next stop, cutting and shaping. Laser cutters slice through metal like butter. CNC machines carve out exact shapes. Tolerances? We're talking micrometers. That's thinner than human hair. Now we enter the welding zone. These robots move at incredible speed, yet every weld is identical. Temperature controlled, angle perfect, speed consistent. A human welder would take hours. This robot, 3 minutes. Look at that precision. The robot arm follows a programmed path to the millimeter. It knows exactly how much heat to apply, how long to hold, and when to move. This is engineering poetry. After welding, it's assembly time. Motors get mounted, gears get installed, wiring harnesses connect. And here's the amazing part. Every robot knows what the next robot will do. They don't collide. They don't hesitate. They're synchronized like dancers. Robot A hands off to Robot B. Robot B positions for Robot C. It's a perfectly choreographed handoff, thousands of times a day. Now watch this delicate operation. A robot picks up circuit boards smaller than your fingernail, places them into position with zero error. A single mistake here could ruin the entire robot. But mistakes? They don't happen. How do they do it? Vision systems. These aren't just cameras, they're smart eyes. They measure, calculate, and verify in milliseconds. If something's off by even 0.1 millimeters, they catch it. Electrical wiring comes next. Power cables, signal wires, communication lines. Every connection tested in real time. Short circuit? The system stops immediately. Safety first, always. Here's where the magic happens. The robot's brain gets uploaded. Lines of code flow in, instructions for movement, speed, safety protocols. It's like teaching a newborn how to walk, but in seconds. Behind all of this is artificial intelligence. A central AI system monitors every robot on this floor. It predicts problems before they happen. It optimizes workflow. It learns from every single operation. This AI gets smarter every day. If a robot arm moves inefficiently, the AI notices and reprograms it. Production speed increases by 2%. The AI finds out why and applies it across the board. This is continuous evolution. Sensors are the nervous system. Pressure sensors detect force. Temperature sensors prevent overheating. Proximity sensors avoid collisions. There are over 50 sensors on a single industrial robot. All that data flows back to the AI brain instantly. If a sensor detects unusual vibration, the system investigates. Is it a loose bolt? Wearing part? Maintenance gets alerted before failure happens. Now let's talk aesthetics.